How to make a Stuart triple expansion engine run, part 16. Drilling the holes in the cladding at this side seems more difficult, although the drilling operation is similar to the other side. But there are some larger holes to drill in this piece of cladding, and it is very easy to lose concentration and make a mess of the job. So I'm going to try really hard not to do that. Here's what I have to work with. This is the side of the engine that the cladding is going to cover. Once again, I'm using my Proxon Micromot drill in the stand on the bench. This is not very powerful, but it's powerful enough. This cladding is made from steel and it's quite hard, but it's very thin. So after a short while, there's a puff of smoke as the drill breaks through because everything's getting quite hot. And that's one hole done. Now for the next one. You will notice that I make multiple indentations before I actually commit myself to drilling the hole. I need to make sure I'm drilling the hole in exactly the centre of the described ring. The initial touches with the drill only scratch the surface and tell me when the drill bit is in the right position, and only then do I apply the pressure to drill all the way through. This next bit may be confusing. Why don't I use a larger drilling machine with a larger drill, instead of using this tool to cut through the holes? The answer is simple. If you drill a larger hole in a very thin piece of metal, the drill bit will generally wander about a bit, and you'll often get a misshapen hole. This thing is brutal, and you always have to make sure that you're going down into the wood. Don't reuse any of the holes that you've already drilled. As the burr drills down into the wood supports it and stops it rattling about, because if it rattles about, as you've just seen here, it's a problem. The cladding only rattled because it wasn't supported. I was reusing one of the other holes. These sets of burr type cutters are incredibly cheap, and they're good. They are really good. And the good thing is the shaft of the burr fits perfectly in my Proxon Micromot drill. This is one of the holes for a cylinder drain. I'm drilling the hole first with the small drill bit, and then I will enlarge it to the size that I need it to be for the cylinder drains. This hole in the corner is to take a 6BA bolt to hold the piece of cladding at the edge. I didn't bother with the bottom one because the hole in the casting is too close to the edge of the cladding. I'm running the video at a higher speed just to get through this because there were quite a few holes to drill and even I was getting bored with it. I'm going to show an accident. This is what happens when you don't support the cladding by going through the wood when you drill it with a burr. And that's the great thing about using a Proxon motor tool. Had I have been using my main drilling machine, I would probably have cut my fingers, but I'm not frightened of this very small drill bit, but as you can see, it is capable of spinning the work around, so be careful. This job seemed to take a long time, and even with the video running at a higher speed, I'm still getting quite bored with it. The point is though, if you get bored with the job and lose concentration, you will make a mess of it 9 times out of 10. Yesterday I was fitting some new rear lights and indicators into my Series 2A Land Rover, and I remember when I first fitted these in 1999, I used some very long Allen caphead bolts. Even at the time I wished I hadn't have done, and removing them was a pain. And it took an extraordinary long time before the nuts came off the end. Here once again I'm demonstrating how you must make sure that the burr goes into the wood and doesn't rattle about. This is the part where I'm enlarging the holes to take the cylinder drains. One of the holes is a bit too large, but you can't have everything. But despite that, after a while all of the drains are screwed into position. I'm going to fit them in place using nut lock so they don't move, but what I need to do is make sure they are very close to the cladding. In this shot they are quite close, but I did get them closer with a bit of experimentation later on. I found out that a few of these drains didn't need any washers and were a perfect fit in the right place. I think that must be beginner's luck. The job isn't 100% perfect at this side, but by the time the piping's in place, I don't think you'll notice that. I've turned the engine round and I'm looking at fitting a displacement lubricator onto a T-piece. I removed the 1/4" adapter from the T-piece because it wasn't big enough. This engine will need to use 3/16 pipe for a steam inlet, not 5/32. And also I'm going to fit a right angle elbow onto the exhaust, which will take 1/4" pipe, and that in turn will go to the condenser that I haven't made yet. If you want performance, then piping sizes are very important. You must never restrict the flow of a gas engine, and of course steam is an invisible gas. The hole into the steam chest is only 1/4 by 32, which is a bit small, but at least the pipe will be 3/16 inch diameter, which will admit sufficient steam to operate the engine. I've temporarily screwed the displacement lubricator in place, but I will have to fit some 1/4 inch shim washers to make it sit in the right place. And that is it for this one, and thankfully that is it for drilling cladding. As always, I would like to say stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.